Today we'll be talking about running large-scale training and inference on GKE. And I'm Alex Zakonov. I'm a director of engineering for Google Kubernetes Engine team. And with me is Nathan, who works on the product side. And we'll be talking both overview of why you run large-scale training or inference on GKE, as well as concrete new developments that we're providing in the product to enable that functionality. First, as TK mentioned, GKE is a key part of Google AI ML infrastructure stack. And that's reflected in growth that we see in the space and in our customer experience. So just over the last 12 months, we saw over 200% growth in workloads running inference and workloads running training on GKE. So which is a tremendous growth, and that's growth on like really big base. So kind of fun. Cannot share the exact base, but it's kind of industry-breaking type of growth. And if we look on the usage coming from all segments of GKE customers, from small to the largest ones. But the key thing is that we see pretty much all our largest customers using GKE for large model training, and as well as running large model inference. So what's unique challenges that we are experiencing in the industry? We see tremendous growth in the model sizes. So kind of this graph represents growth that we see with GPT-2, GPT-3, with GPT-4, with Palm, with Llama models. And that growth doesn't stop. Why is that growth happening? Because as we increase the model size, we see fundamental shifts in the model capabilities. So we're going to be on that trend for a while. Like what exactly will happen, where exactly the trend will stop and will go to a more plateau, still to be seen. But at current moment, we're in that rapid growth phase. And each next layer unlocks new business possibilities for our customers. And why our customers use GKE? Like, what's behind that? First and most important is we're going through that fast scaling phase. You need to have a platform that both can scale dynamically with you to really high limits, but also do it in a cost-efficient way. Because for the large models, training, extremely expensive. Inference is also extremely expensive. So unless you have a solid platform that provides all the foundation for performance and price performance, it can be really dangerous from a healthy business standpoint. Second, key thing is we're in a rapidly changing market. So in a rapidly changing market, your time to market, time to value for your customers is super critical. So one of the most important things is how fast you can bring new capabilities to your customers and how fast you can validate those new capabilities. So with GKE, we provide a standard platform that spans across all your application types. That spans across your traditional web apps, stateful apps, batch applications. And now bringing AI/ML training and inference on top of GKE, what it means, they can reuse all the best practices. You reuse all the policies that you have within your organization for what it takes to prepare application for production. So it's your one standard platform that provides fast time to market for enterprise-ready applications. The last key point is AI/ML is still extremely new space. And what it means that we'll see significant churn in tooling, in ecosystem in the next couple of years. Like you see new frameworks, new offerings, new OSS tools coming up almost weekly. And GKE is based on Kubernetes. Kubernetes is an open and standard platform. And what we are doing, we are making sure that in that highly and fast evolving space, we provide the open foundation for you, that you are not locked in a specific tooling. So how that translates to concrete investments that we're doing on GKE team to support you. And I'll start from the bottom of the diagram. First is GKE foundational AI/ML platform. So in the foundation, one of the key things that we see is for large models, high-speed networking is one of the key things to enable large-scale training. So we invest a lot in integration with GCP networking, both on a GPU side, on a TPU side, to unlock training scenarios. Second, both for training and inference, storage performance is super critical. Pretty much, as we think about for inference, latency, load time for the models is one of the key characteristics. So we partner very closely with GCP storage teams to enable differentiated storage performance as part of GKE clusters. So that's a foundation. And in that foundation, we ensure that we cover all compute platform options across TPU, that was announced yesterday, GPU, and CPU. So you get consistency of compute as you rely on GKE. As we look on specialization between training and inference workloads, the key investments in training is on hyperscale clusters. GKE today provides larger scale Kubernetes clusters. So we support a single cluster up to 15,000 nodes. And we support multi-cluster architecture with GKE Enterprise. So training is really pushing the boundaries of training, both within single region, multi-region, enabling the scale that you need. On inference, the balance is different. On inference, the key things is latency of your inference models, price performance, because especially for the large models, serving is super, super expensive. And third is a high throughput for models that are successful for your business. So that's three key areas of investments that you will see happening in GKE as we integrate inference offerings in the GKE. The last point, going to the top of the diagram, is ecosystem. As I mentioned, AI/ML and Gen AI is a highly, highly dynamic space. And in that highly dynamic environment, variety of tools that we'll all be using is gigantic. Yeah. And the key investments that we're doing on a GKE both provide out-of-the-box integration for all popular OSS frameworks. And we're also partnering with early startups, early OSS frameworks that still on the rise, providing open platform for that. With that, I will pass to Nathan to cover in details investments that we're doing both on the training, inference, and ecosystem side.
Thanks, Alex. So I'll start by discussing how GKE enables large-scale training. And to structure our discussion together, we can think of a typical architectural cake diagram. A successful ML training experience depends upon amazing foundational infrastructure. Kubernetes then provides the critical orchestration layer. And above that, an open source Kubernetes native system called Q provides many of the features you need to manage jobs. And on top of GKE, you are running your ML frameworks, tools, and libraries. I will start at the bottom of the stack and work upwards. So first, GKE provides diverse and industry-leading accelerated compute options. Now, most managed Kubernetes offerings support GPUs. But today, I am thrilled that we have announced that GKE is the first managed Kubernetes offering to support tensor processing units. Google's custom-designed machine learning accelerators are now generally available in GKE. We've brought together the remarkable price performance offered by TPUs with the industry-leading scalability that GKE provides. Customers like Character AI, Lightricks, Weights and Biases, and Grammarly are already experiencing some of the benefits of TPUs in GKE. If you're already using cloud TPUs, GKE can save you money and simplify your operations by scaling up when demand rises and scaling down when demand falls. Lightricks, an AI-first company that develops photo and video editing apps for creators, found that TPU support in GKE has replaced many of their custom scripts that they built to operate their large model trainings. Weights and Biases, which provides a developer-first MLOps platform, has worked with Google to add support for cloud TPUs to their launch product. And their TPU support is built on GKE. In Grammarly's research on large language model alignment, Grammarly found that Google Cloud, TPUs, and JAX outperformed many similar offerings that they evaluated along dimensions of performance, reliability, and scale. And in his keynote yesterday, Thomas introduced the Cloud TPU v5e, our most efficient, versatile, and scalable AI accelerator. And today, I am thrilled to announce that the TPU v5e is available as a preview in GKE. v5e offers up to 2x more performance per dollar for training workloads compared to our previous generation of TPUs. v5e is designed to offer highly flexible VM shapes to perfectly fit your diverse workloads. And our multi-slice technology enables v5e to power massive ML workloads that scale to tens of thousands of nodes. I'm thrilled as well that in the coming weeks, the A3 VM, powered by the NVIDIA H100 GPU, will be generally available in GKE. Training very large ML models requires tremendous network throughput between nodes. So we designed the A3 to have an order of magnitude more network bandwidth compared to the previous generation. With 8 H100 GPUs in a single VM, the A3 provides a remarkable 26 exaflops of AI performance, shrinking the time it takes to train models. The A3 is revolutionary, and customers like Tab9 depend upon it to power their business. Tab9 offers an AI-powered code completion trained on permissive open source repositories. To compete, Tab9 depends upon the speed and price performance of A3 VMs running in GKE. The power and scalability of the A3 in GKE allows Tab9 to rapidly build, train, and serve each of their customers in a way that's personalized to their private code. I've spoken several times about the diverse options GKE provides for accelerated compute. Our A2 Mega VM is unique among all hyperscale public clouds. It's the only VM offering 16 A100 GPUs on a single VM. With 16 A100 GPUs on a single VM, many customers find that A2 Mega's unique shape can offer superior price performance for training large workloads. AI21 Labs is one of the leaders in developing foundation models. They have found that the A2 Mega helps them cost-efficiently run their products and R&D workloads because of the A2 Mega's unique configuration of 16 A100 GPUs. Salesforce AI Research found that A2 Mega makes it easier to fine-tune large models and saves time during model training. We've seen that GKE's diverse, flexible, and powerful accelerated compute options are one key way GKE enables you to train massive ML models. Another essential aspect of training large models is getting fast access to lots of data. And that's why I am thrilled that today Google Cloud Storage Fuse is generally available on GKE. Fuse is short for File System in User Space, and it allows application developers to use common file I/O operations to access GCS rather than using GCS-specific APIs. If your workloads fetch unstructured data, now you can move those workloads to GKE without requiring any change to how you access files. Standard Python file semantics work out of the box to fetch data from Google Cloud Storage, making your applications more portable than ever before. GCS Fuse can also speed up the time of your application by allowing it to load data and start processing that data before all data has finished loading. Customers like OpenX are already using GCS Fuse with GKE and have found it vastly simplified configuration of their applications and accelerated pod startup time by up to 40%. On top of a diverse, powerful, and easy-to-use foundational platform, GKE adds the very best of our managed Kubernetes offering. GKE supports the training of massive ML models by scaling to as many as 15,000 Kubernetes nodes in a single cluster, outscaling other public clouds by up to 3x. Because the scale of ML models is increasing far faster than the size of hardware accelerators, a multi-node training architecture that supports massive scale is critically important. And GKE uniquely offers that. As the number of nodes in your training cluster increases, the probability that any one of them will fail naturally increases as well. Since one node failing means all nodes must wait, we've made extensive investments to help you maximize workload uptime. GKE's proactive notifications give you advance warning about potential breaking changes in future Kubernetes releases. And our maintenance windows give you control over when upgrades happen. If any unplanned node failures occur, GKE can detect and auto-repair the node while allowing training to resume quickly. When training ML models, you need the entire job to get done, with all pods working together as a unit, and with many different teams sharing access to limited compute resources. So to make this easier, we've invested in Q, an open source, Kubernetes native job queuing system. If you have many teams within your organization all sharing limited compute resources, Q makes it easy to share those resources together. With Q, each team can get their fair share of resources, while bursting to take advantage of unused resources elsewhere. With Q, the most important jobs get priority, and lower priority jobs get preempted. And all of this is fully open source and integrated with a diverse ecosystem of ML tools, frameworks, and libraries. We know GKE is just one piece of your overall AI journey. So that's why we support a diverse ecosystem of tools, frameworks, and libraries. So we've seen GKE provides pay-as-you-go access to a world-class supercomputer whenever you need it for training ML workloads. Let's see how GKE enables high throughput, low latency serving. So just like training, I'm going to start by looking at the foundational infrastructure that GKE provides, and we'll work up the stack. A few months ago, we announced the general availability of the G2 VM, powered by NVIDIA L4 GPUs. G2 is the industry's first cloud VM powered by the NVIDIA L4 GPU, and it's purpose-built for AI inference workloads with up to 4x better performance than the T4. By switching from the NVIDIA A10G GPU to G2 instances, organizations can lower their production infrastructure costs by up to 40%. Unlike the A10G or the T4, the L4 GPU includes FP8 support, which can drive even better price performance for serving workloads. I spoke earlier about how easy it is to chain together many TPU V5E chips into a massively scaled supercomputer for training workloads. The V5E has very flexible VM shapes, making it stellar for inference as well. With up to 2.5x more performance per dollar for inference workloads, and up to 1.7x lower latency for serving LLMs compared to the prior generation, V5E can provide an affordable, low latency serving for your ML models. On top of our inference optimized hardware, GKE adds amazing Kubernetes goodness to make serving models fast, reliable, and affordable. Traditional Kubernetes offerings, even many managed Kubernetes offerings, still require that you manage your Kubernetes nodes. To help you focus more on your business and less on infrastructure management, we built GKE Autopilot. Autopilot is a mode of operation in which Google manages your cluster configuration, including your nodes. Autopilot is perfect for ML serving workloads, allowing you to build and deploy faster without the need for deep Kubernetes expertise. The resources requested by your Kubernetes pods are backed by Google SREs, reducing the burden of day 2 operations. We found customers love Autopilot for ML serving workloads. So I've talked about how GKE is an ideal home for your large-scale training and serving workloads. But as workloads scale, costs tend to grow as well. So I want to spend a final few minutes discussing a ton of ways that GKE helps you optimize your spend while maintaining your customer experience. One of the best ways I've seen customers save money doing inference is to remove from their container image any unused NVIDIA libraries and to serve using NVIDIA Triton and Faster Transformer. One customer that I spoke with was able to achieve a 75% reduction in the size of their containers by doing this. I've seen other customers move inference workloads from a single A100 GPU to a multi-host inference architecture in which the model is split across many smaller GPUs, such as T4s. And in exchange for slightly increasing your serving latency, this can lower your GPU costs by up to 50%. In GKE, auto-scaling and node auto-provisioning makes it very easy to serve primarily using spot GPUs, which are up to 90% cheaper, but to fall back to on-demand instances when spot becomes unavailable. Whenever you're serving user-facing traffic, you'll generally want to provision slightly more GPUs than immediately necessary in order to absorb a sudden spike in demand. If it takes your pods a while to get scheduled on new GPUs, then you'll need a large GPU buffer, which raises costs. So we've invested extensively to ensure that new GPUs can spin up quickly and your workloads can get started right away. GKE image streaming provides you with up to 3x faster application startup by allowing your workloads to initialize without waiting for the entire container to download. And as I mentioned earlier, GCS Fuse, we've seen customers using GCS Fuse on GKE reduce by 40% their workload startup time for data-intensive workloads. Many organizations also share infrastructure across numerous teams. GKE provides built-in metrics, dashboards, and alerts to measure and attribute per-tenant costs, as well as powerful tools to increase your compute utilization for each team within your organization. One of the ways that you can save money is by using many containers on a single GPU to then increase your GPU utilization. And GKE's GPU time sharing allows multiple containers to share a single physical GPU, allowing you to more efficiently use GPUs. This can be perfect for bursty workloads like notebooks or low-volume inference. GKE's multi-instance GPU support allows you to partition a single larger GPU into several smaller ones, perfectly fitting each of your ML workloads. And in the coming weeks, GKE will support NVIDIA Multi-Process Service, which provides an additional way to let applications share a GPU concurrently, helping you to increase the utilization of your GPUs and lower costs. We've seen how GKE is a stellar platform for your AI workloads, enabling cost-effective training and serving. And that's certainly true. But what makes GKE even more powerful is that it can do this not just for your AI workloads, but for all your containerized workloads. Customers like Lightrix rely on GKE's diverse hardware accelerator support by mixing and matching TPUs and GPUs. And Lightrix uses TPUs for efficiently processing text prompts in batches, using a large text encoder, and then employing GPUs to run an in-house diffusion model. There's no other orchestration platform that offers such a diverse mix of TPUs and GPUs. Customers like Lightrix and Salesforce, Grammarly and AI21 Labs, Tab9 and OpenX, and so many others depend upon GKE as part of their AI journey. And I am excited to see all the ways GKE can partner with you in the coming months to play an essential role in accelerating your organization's AI journey.